We have two great talks this afternoon to round us out. And our first talk will be the Homelessness Hub at UC San Diego using GIS to advance spatial knowledge. And just as a quick set of reminders, they will have 15 minutes to speak and 5 minutes for questions. And questions will need to be asked in the chat as not everyone has the power to unmute themselves with our Zoom setup. So, team, take it away.
Thank you very much. Good afternoon, everyone. Happy GIS Week and UC GIS Conference. My name is Julie Wartell, and I am a continuing lecturer and staff research associate at UCSD. And with me today is our GIS data team from the Homelessness Hub. And also wanted to acknowledge with us today is Amy Work, our GIS librarian at UCSD, and who has also been instrumental in the Homelessness Hub development, and we go to her with all the hard questions. So who are we and what do we do? So in 2020, I got a message from a colleague who was part of a group of researchers throughout San Diego County from all colleges and universities, anyone that was doing research or work on homelessness. And she sent me a message and said, can you map the 311, or it's called Get It Done in San Diego, the complaints for homeless encampments? And there's data available, luckily, from the city of San Diego. So I downloaded it, made a basic map, texted it to her. And I guess everyone said, wow. And then she said, can you put the parks and bus stops on there? Threw those on there. And what that turned into was a small grant to start the Homelessness Hub. So we started as a basic GIS portal with homelessness related data and maps, filling the gap of no one else in San Diego County was looking at. We have lots of different individual maps, individual data out there, but I want to get services. I can go to 211 and see dots on a map. But no one was really using GIS or spatial data or much data at all to look at homeless issues. So we started with a little bit of a few percent of our time from a few people, got a couple of great students on board. And then in 2022, we actually got some private funding to expand. And we now have 5 faculty staff members, 2 postdocs, and 6 undergrad research assistants to round out our cadre, as well as, of course, Amy providing excellent support and the library itself providing support. So while GIS is our history and GIS is still at the core of a lot of what we do, that we've gone beyond GIS. So not all projects have a GIS component, although we always try and find that spatial component, as I'm sure all of you involved in GIS feel the same way about, well, if there's something about a location, we can do some spatial analysis, right? So we've got numerous collaborations and studies from very small to very large. And what we hope to do is continue to expand in the future, more applied research and more evidence-based and data-informed policy. And that's really what we're about. We're definitely not about doing research just for the sake of research. We really want to contribute to data-informed and evidence-based policy. So a few past projects and partners that I wanted to acknowledge or recognize because they really helped get us started and helped see the value in the Homelessness Hub existing. So the San Diego River Park Foundation was really our first partner, and they have been collecting data for several years on trash or abandoned encampments in the riverbed. Those of you not familiar with San Diego, the San Diego River technically goes from the ocean in Ocean Beach all the way to Santee, about 30 miles inland. Not a lot of water in that river. You're not kayaking in that river, really, but there are a lot of people living in that riverbed. So they had just started a project with one of our biggest outreach social service providers, people assisting homeless, called PATH. And they were partnering in the riverbed. So we used Survey 123 and created a little survey for PATH to when they went out there to collect data about people living in the riverbed. because it was during COVID, they actually used that to help them identify where people and needs were, as well as occasionally when it rains in San Diego, they want to go down there and know where the people are living. And there really had never been a full-on census of people living in the riverbed. That actually led to a project with the Southern California Coastal Water Research Project, also known as SCORP, about measuring contamination in the riverbed from the homeless people living in there. So again, we use Survey 123. The PATH folks worked with the SCORP folks, and so we were on the more the creation development of the tool end and contributed a bit to the analysis down the road. And our findings were that the people that were living in the riverbed, that were pooping in the riverbed, were not actually contributing to a higher amount of contamination that was already in the San Diego River. A big project that we ended up working on was the Eviction Prevention Collaborative that was based out of City Heights. It's now based out of the Legal Aid Society. And again, using Survey 123, as you'll see a theme here, that we worked with them to collect data on two projects. One was to register people for workshops. They held workshops throughout the county, mostly in the city. And so we collected data there, and then collecting data from all of the different social service providers about the outreach that they were providing. That actually we created dashboards for as well. So the public and the partners could monitor where and when and who were being provided eviction prevention services. The last one, the UC Institute of Transportation Studies. We got a preliminary grant, and we actually just recently got a secondary grant to that, looking at affordable housing and transportation. So super in-depth study, super interesting. That's still growing, changing. A lot of things are going into that, but that is definitely GIS and spatial based. The next projects that I want to introduce are actually going to be discussed by Daniel, Michael, and Haven. And these are current projects that we're working on. So the Downtown Partnership is essentially the Downtown Business Association for the city of San Diego. And they have been collecting data on paper maps with pencils since 2014. Walking around once a month and collecting data on where homeless people are living, either just out on the street, in a vehicle, or in a tent. And so the San Diego Regional Data Library, which is run by Eric Busboom, had been collecting data on a wide variety of things, and unbeknownst to us until we realized it, had worked with some students previously not from UCSD, taken these maps and created a process to digitize them. But that had stopped in June of 2018. So our team, and Daniel's going to describe, processed, mapped, and are analyzing all the way through 2022. The single room occupancy hotels that Michael will be describing, looking at single room occupancy where oftentimes unhoused people are staying for short or even longer amounts of time, looking at how that changed over time. The next project, also Michael, eviction moratorium analysis. So one of the things that came out of the partnership with the Eviction Prevention Collaborative was some additional work mapping and analyzing eviction related data. And I'll let Michael tell you more about that. And then lastly, what Haven's going to talk about is our original Homelessness Hub GIS portal. So we're using Esri Hub technology, and we have lots of data, maps, and more on that. So with that, I'm going to turn it over to Daniel.
Perfect. Thank you, Julie. So like Julie said, the UC San Diego Homelessness Hub has collaborated with multiple different organizations in San Diego to keep track of where homeless people are living in the San Diego area. And one of those organizations is Downtown Partnership, which keeps track of homeless people in the downtown area. And so the link on the screen, which was made in collaboration with the San Diego Regional Data Library, shows the full results of the research and digitization of the data And I strongly encourage everyone here to check it out because there's some really cool data visualizations, data processing. But here on the screen visually, we made a simple map of the total number of homeless people counted by the Downtown Partnership since 2014 in each neighborhood in downtown San Diego. So you can see that the red neighborhoods in the middle, East Village, the Gaslamp District, and the city center were where the majority of the homeless people have been living, which is probably not a surprise for anyone who's from San Diego. Where fewer people were living on the outskirts of the downtown area, maybe in like Barrio Logan. And then on the next slide, we'll look at how the locations of homeless people have changed over time since from 2014 to 2022. So next slide, Julie.
Sorry.
Thank you. So here you can see the point data of where each individual homeless person was located. They were counted by the Downtown Partnership, along with a heat map of the most common locations. So in total, from 2014 to 2022, the Downtown Partnership counted more than 81,000 people, but there were pretty clear trends in where these people lived and where they moved around. So on the screen is the map for 2014. There were 5,832 individuals counted by Downtown Partnership's teams. And you can see on the center of the map that homeless people tended to be clustered in the East Village South and the city center neighborhoods. And there were basically 0 people counted on the neighborhoods on the outskirts of downtown. And next slide, please. And then looking at the map from 2022, so last year, it's clear that things changed a lot since 2014. The most obvious change is that the number of people counted more than doubled to 13,248 people in 2022. And you can see that on the map visually, the area is a lot more crowded with homeless people. So they've begun to spread out and live in the kind of the outer neighborhoods. In addition, the area with the most homeless people counted was around the Gaslamp and City Center North neighborhoods. So we can see that this project and the data visualization is a pretty good way to view where homeless people are living. And it also provides a good opportunity to learn about where we should focus homeless services to be able to better provide them with food and shelter and long-term housing, and where we can more effectively do outreach to homeless people.
Next project looks at single room occupancy hotels, or SROs, which are some of the most affordable housing options in urban housing markets. Using data from the San Diego Housing Commission covering 6 years, 2002, 2012, 2016, 2021, and 2022, and 2023, most recently, we have been able to map the decline in the number of SROs in the city of San Diego since the early 2000s. Independent researchers from Homelessness Hub have been able to verify the number of SROs in each of these years, and comparing them with the numbers from San Diego Housing Commission, they are much lower than they report. So using this map, we can see that SRO loss is happening much more quickly than the San Diego Housing Commission can document. As an affordable housing option with low barriers to entry, SROs need to be preserved and additional SROs should be constructed. Currently, we're working on incorporating this map into a story map that will also communicate the experience of people living in SROs. For this project, we looked at eviction moratoriums and their effects during the COVID-19 pandemic. Using data from the San Diego Superior Court and sheriff lockout data from the San Diego Police Department, we've been able to estimate the effects that these moratoriums have had on the number of eviction filings and sheriff lockouts, which represent the end of the eviction process. On the right is a map that visualizes eviction filing rates by zip code for 4 different periods based on different county and city eviction moratoriums. As you can see from the map, eviction filing rates changed drastically during these 4 periods, decreasing during pandemic eviction moratoriums. We're currently working on 2 story maps that will cover eviction moratoriums as well as eviction trends overall.
Yeah, and then now going into the original purpose of Hub, as Julie mentioned, the first thing that we ever had and the thing that we're still running now is the Homelessness Hub ArcGIS portal. So inside the ArcGIS portal, we have 289 pieces of content, and that number actually increases to 300 if you include all the content we have in the portal that is from other collaborators of Hub as well. And this content isn't just data or shape files. So a lot of it is, but some of it is also the Survey 123 forms that Julie mentioned earlier. Some of it is story maps that we have created for for public engagement, that kind of stuff. And it's all located inside a portal for organization purposes and so that everybody has a place to access it. And as you can see, we have split it up into 18 groups, 18 different content groups that have different varying levels of access. And the reason why we do this is because not all of our data is publicly accessible. Some of it is only for internal use, such as the survey results or like certain more sensitive pieces of data that we use only for internal research projects. And some of it is public facing for the members of the general public to inquire into. And one thing about having so many pieces of content is that we have a lot of tags. So that is one thing we encountered having an issue with, is that we just in our content group, we had 62 tags, and managing tags was an issue. But that's why we have on the top right, you see in the blue border, we have a separate tag bank that we use to refer to our tags. And then moving on to the next slide. The data repository is, you can see there's a QR code in the bottom left that guys can scan to get to the data repository. Basically, it's a public facing website that members of the general public can use to get into, to understand more about the data that Homelessness Hub provides. So for example, we showcase story maps that students have created in classes that faculty at Hub teach, and we try to reciprocate that back towards what we do at Hub. And then we also have a My Map app that we created, which allows for the general public, especially those who don't have GIS experience, to experiment and play around with the different kinds of data that we provide, and allows them to explore more about homelessness data in San Diego. Yep.
Thank you. Any questions or comments from anyone?
Thank you to the UCSD Homelessness Hub team. Again, please put your questions in the chat and I can read them out so we can talk more about this project.
One last thing, this QR code over here leads to our Homelessness Hub website. So if you want to see all our projects.
Come on, someone has to have a question.
We do have one question from Anthony. Have you worked with the COC on any projects? Or have you collaborated with any cities in the county? Kind of ties in from Edie as a follow-up.
It does. And I don't know if Anthony's a plant. I got to be diplomatic about my answer on that one. No, I'm just kidding, Anthony. The Regional Task Force on Homelessness is the San Diego County COC. And while we have worked with them, we still have some challenges in getting data from them. So we are currently working on a big evaluation of the shelter system with them. It's the PIT count, the point in time count that everyone does throughout the country, that we receive data, and they actually have public data in 2018, but have had a variety of reasons why they have not shared any data since then. So still working on it. In terms of the cities, we have peripherally, we did some work with Chula Vista on some water related back in the riverbed days. Carlsbad we've met with, but no official projects that we're currently working on.
Another question comes from Ryan. Question about data and access. Any thoughts or movement on using alternatives to Esri for your data hub and presentation?
No, we're currently an Esri shop. We have a ton of resources. I mean, we use Google, we use other things. We're using Globus to store any non-spatial data, and working together on that. But pretty much any spatial GIS related, we're using Esri products.
And this question from Andrew will be our last question for this session. Does encampment location data strictly rely upon 311 reports, or are other methods used as well, specifically utilizing aerial imagery?
Another great question. Currently just 311 reports, which we have for the city of San Diego only. We do not have those for the county because they're not available for other cities, as far as we know. But using aerial imagery is a great idea. Just sideline, although we've talked about kind of trying to replicate. I'm working with Boulder, Colorado on encampment issues, and we have collected a variety of ways of collecting data around encampments beyond the 311 reports there. So happy to talk to anyone offline as well. You can shoot an email to the email address or jwartell@UCSD.
Awesome. Thank you all so much again for your wonderful and thought-provoking presentation. And I'm now happy to introduce our last talk for today by Darina Pospelova, who is going to talk about Puma movement ecology mapping. So Darina, you can take it away.
Awesome. Thank you so much. My name is Darina, as mentioned, and I'm an undergraduate student at UC Santa Cruz. And it's so great to be presenting here today. I'm very excited to talk about how the implementation of GIS has facilitated and driven the analysis of research like this. So over the summer, I worked at the San Diego Zoo Wildlife Alliance under the mentorship of Dr. Jessica Sanchez. And I'll be sharing some of our updates relating to Puma spatial epidemiology. So for some background, it's important to kind of mention that one of the most primary threats to Puma populations in California is habitat loss and fragmentation. So here we want to bring attention to how such drastic changes to the natural landscape could facilitate disease transmissions through inter- and intraspecific encounters. So disease can impact populations in a number of ways, especially when we account for all the changes and threats that pumas are constantly being exposed to. So with such a strong potential to alter patterns of exposure, there becomes a definite need to address the knowledge gap regarding the impact of toxicants and pathogens on population health. And so the goal of this study is to determine if there is a relationship between habitat types and disease status. If we determine a habitat to be associated with high risk of disease exposure, and we see that pumas are preferring these habitats, then we can ultimately expand our overall understanding of how disease is being transmitted through California's puma populations. And so this study consists of several stages, and over the summer, I worked primarily on the methods for phase 1. And so this first phase here intends to quantify how intensely pumas are utilizing different habitat types. And I'll go into more detail about how we did that in the next couple of slides. And so as for the rest of the phases here, we're working to determine preference and avoidance of habitat types that will then be connected to a disease model to assess whether pumas are actually spending time in areas that are associated with high risk of exposure. So going back to phase 1, I began cleaning the data set and removing outliers. And then we calculated utilization distributions for all individuals using a dynamic Brownian bridge model. And then we imported a land use raster that we then overlaid with those calculated utilization distributions to then get an overall quantification of habitat use. And so in order for our data set to work with our spatial model, we had to complete some initial filtering to remove and address irregularities. So we calculated speed for all consecutive locations because we needed to define a cutoff for removing inaccurate location fixes. And so based on some literature reviews, we determined that a puma can comfortably walk at around 2 meters per second. So with that being our threshold, we tossed all locations that exceeded that limit, which only ended up being about 1,000 locations out of a total of over 400,000 observations. So this definitely didn't raise too much concern. And another issue we had to address were gaps between fixes. And so older collar models that were deployed in the early 2000s were a lot less successful in capturing timely location data. And so these technical issues left us with irregularities in signal transmissions, which then ended up creating these small gaps in our collaring periods. And so this graph here on the right is an example of what those gaps between fixes could potentially look like. And this is an individual from the Eastern Peninsula region of Southern California. And so here you can see that over the span of a month, we're getting gaps that sometimes last a little over a day. And then we also have some gaps that last over 3 days, like this. And when we're estimating utilization distributions, our model is attempting to interpolate between these successive locations that have days worth of missing data. And we end up with utilization distributions that have really low probability buffer areas like the one you see here. And so the uncertainty of where the animal may have been is very large. Or in other words, the animal could have been anywhere between these gaps in time. And so the solution for this is to remove the variance of the segments corresponding to these large time gaps. And so for that reason, we created bursts. And we basically define these bursts as clusters of locations that are separated by gaps of time larger than 1 day. And so out of the 99 total individuals in our data set, we had 60 of them that had data gaps that exceeded our threshold. So we created bursts for them with the intent of preventing our model from interpolating these gaps. And so we know that high interval fixes will pull in the probability density around actual location data, creating a much more defined estimation like this one here. And so as a result, the spatial model is now taking all of these bursts and rescaling them into one final utilization distribution so that each individual still ends up with one estimate for its path. And so the data set we worked with is really informative because we have 21 years of location data for a total of 112 individuals that span through several regions. So these Southern California pumas have been monitored since 2001 by UC Davis. And so we're primarily looking at 3 distinct regions. We have the Tehachapi, the Santa Anas, and the Eastern Peninsulas. So the Tehachapi is the northernmost population in this data set, and this region differs the most from the other 2. So this area encompasses the Sierra Nevada mountains, and it includes a lot of forested habitats. And it's also nestled between the San Joaquin Valley and the Mojave Desert. So, and then the Santa Ana and Eastern Peninsula regions share similar land use types, but they differ in the amount of human modified landscapes that encompass them. And so overall, these 2 regions consist of a lot of shrublands and grasslands. So once we completed our initial filtering, we were left with 99 pumas, 9 of which were from Tehachapi, 40 from Santa Ana, and then 50 from the Eastern Peninsula. And so moving on to our spatial model, we want to quantify habitat use with utilization distributions because we are connecting disease exposure to where pumas are actually spending their time. And so the reason why time is an important variable in our analysis is because we're relating it back to disease. And since exposure risk can increase with the amount of time spent in certain areas, we have to take this metric into account. And so if we want to focus on the occurrence distribution of an individual's track, we can use this dynamic Brownian bridge movement model to give us our estimated utilization distributions, which are also referred to as UDs. So these UDs give us an approximation of where the animal was located and how long it spent its time in this location, given the total amount of time it had available to it. And that the dynamic Brownian model differs from other models that are commonly used to calculate UDs because it's capable of describing space use of realistic, behaviorally heterogeneous tracks. And so this model takes into account behavior by looking at things like start and stop locations, elapsed time, turn angle, and speed, and it creates a probability of an animal being in an area between 2 consecutive points. And then one thing to note about this model is that it's known for its ability to calculate UDs despite having irregular fixed rates. So this model works very well with fixed rates that are not standardized, which is great for our data set since we had some variations between fixes. We had some that were 15 minutes and then some that were 4 hours. So here on the right is what a UD looks like for one of our pumas. And we're looking at core areas of use. So everything highlighted in red is basically utilized the most, meaning a puma is spending a lot of its time in this area along its path. And then because this model takes time into account, it's essentially producing a 3D representation of intensity of use. And it's creating these peaks in areas of location clusters, like this 3D model here on the left. And so in this way, we can basically say that our UDs are not a classification of home ranges, since we're actually portraying intensity of space use in a third dimension, rather than just quantifying the overall area of use. So once we made our data compatible with our movement model, we overlaid our UDs with a land use raster to quantify what habitats each of the 3 populations are using. And so these are just some of the preliminary results from what I worked on this summer, and we're using it as an example to illustrate where this research is going. And so we summed the percentage of time spent in each land use category for each population, and we compared it to what was available. And again, we calculated land use with these UDs because we presume that where the pumas spend their time is where they're going to be exposed to disease. And so looking at this graph, we can see that the habitats in the Tehachapi region differ from the Santa Ana and the Eastern Peninsulas. The Tehachapis have much more needle leaf forest available to them, which is the category in the dark green. And they're actually utilizing it quite a bit as well. And the Tehachapis are also have much more temperate shrublands compared to subtropical shrublands. And this is just due to it being further up north. And it's also just due to the way that this raster layer classifies different ecoregions. So knowing what's available and what they're actually using can tell us a lot about puma preference and avoidance for certain land use types. With these preliminary findings, we were able to calculate a global selection ratio to observe behavioral decisions for each population. And so in this graph, everything above the red line will indicate a preference, and then anything below it is going to be an avoidance. So one interesting thing we found here was that the 2 populations that had wetlands available to them actually showed a preference for that land use type. And one quick side note to make here is that the wetland category for this raster layer is effectively just a riparian corridor. And so, yeah, despite it making up a very small amount of their habitats, individuals from the Santa Ana and the Eastern Peninsula regions were spending a good amount of time in these riparian landscapes. And another important observation to point out is that urban landscapes were avoided by all 3 populations, which isn't necessarily surprising, but it does speak to the spatial model's ability to indicate preference and avoidance of habitats pretty accurately. So for the next steps, after we've quantified use, we'll work to describe the associations between habitats and disease exposure to determine if pumas are preferring habitats where disease is prevalent. And moving forward, Dr. Sanchez will collect disease samples, which she will then relate back to the results of our spatial model. And so let's say, for example, those riparian areas that we talked about earlier are actually associated with a higher risk of leptospirosis, which is a disease that can be transmitted through still water. Since we've shown that pumas are preferring those areas, and these areas are corresponding to disease prevalence, this situation could potentially reflect an ecological trap, at least in terms of the effects of disease on fitness. And so, yeah, this is definitely still ongoing work. It's a very big project, but I am very happy I got to share some of it here for you guys today. And lastly, I'd like to give a special thank you to Jessica Sanchez and Matthias Tobler for their support and guidance through this fellowship, And I'd also like to say thank you to Winston Vickers and the team at UC Davis for collecting and sharing their location data. Yeah, and if anyone has questions, you can email me or we can ask them now if we have time. Thank you so much.
Thank you so much, Darina. We already have a question in the chat from Andrew Wallace. Do you have
Mhm.
any plans on sharing this data or results with land managers in the areas of study?
Yeah, so this project is part of postdoctoral work with Dr. Jessica Sanchez, and so this is definitely something that she's planning on publishing in the future. So yeah, and I can also forward her contact information as well and her email for details on that if you guys are interested.
We've got a quick comment from Dave Brewster that the California Fish and Wildlife does a lot of work on mountain lions and their habitat. Hopefully you can share this analysis with them in the future. And then a
Mhm.
question from Annika. The individuals in the study represent a variety of age ranges and balanced genders. And asking for clarification, do they travel actually at 2 meters per second? Because that's crazy fast.
Yeah, so that was our threshold. So basically, when we were filtering the data set, we said that is the highest that we will basically allow any of our data to go. So if we have any points that are higher than the 2 meters, then we can just say that that is an outlier. And it was just a miscalculation or something was wrong with the caller. Yeah.
Any other questions for Darina before we wrap up for today? All right, I want to give a huge thank you and round of applause to all of our presenters from today. And a huge shout out to Ryan Horn, our mostly fearless leader, for helping to organize this conference. It is not easy to organize a conference. And thank you all for being here. It's really great to have people out in attendance to get to see all these wonderful talks as well. And I hope you'll be able to join us in the following 2 days for hopefully another great set of days of presentations, lightning talks, and more. So thank you all and have a great Tuesday.